Hello guys! So today is another video in my fun and educational videos channel. So I know you're wondering what is today's video about and why am I talking? Well, today's video is about dark matter and dark energy. Both of them are so awesome and cool and also ordinary. Many people don't know about them. So first, I'll talk about dark matter. So what is dark matter and where is it? But before that, I think you're thinking that dark matter is matter that is dark. Well, you're 50% correct. So what is dark matter and where is it? Well, dark matter is matter that is invisible. And that's where you are 50% correct. And where is it? Well, since it's invisible, that means you can't see it. But it's actually everywhere. Like, you don't even see it, but you think it's like fresh air, but it's really like everywhere. Yeah, so that's how dark matter is. And if dark matter is like that, then why do scientists want to like learn more about dark matter and dark energy and like find out? Well, it's because it's important for our lives. Like dark matter and dark energy, not really dark energy, but dark matter is so important for our lives. Yeah, and you might be thinking, why is it important for our lives? Well, it's important for our lives because it helps stars being big clusters. Yeah, but you must be thinking, why? Well, maybe in a movie or somewhere you must have seen a galaxy or stars being big clusters, which is called a galaxy. So why is that happening? Well, the stars are not really sticking, or then they'll explode. So why are they sticking together? Not exactly sticking, but why is gravity holding them? Well, it's because of dark matter. Dark matter is in the sides of all of the galaxies, and then it helps the stars being big clusters. That's so you can see a real galaxy. And you cannot really see the dark matter. And without dark matter, then all the stars and planets would be floating like this, which is not good. Yeah, and also it's not good, and plus something might happen. Of course something might happen very bad, so we don't want to take risk. So if dark matter is like that, and since it's invisible, then you must be thinking, how do scientists figure it out? Like, how did they find out dark matter? Well, there are some reasons, like about 2 reasons I know. So one reason is that, like, I don't know if you know, but black holes are in the middle of like all of the galaxies, and they help the stars be in big clusters. Like they used to think, and it's actually real. Like they spotted one in the middle of our galaxy, but like years before, a scientist did some equations and found out black holes are not so strong to hold a galaxy. They could build a cluster. Well, not exactly like this, but it's not really strong. That's what the photo explains. So that's how it is. And if it's like that, it must mean that there's something else out there. So he thought it was dark matter, but it was not really true. So like people were saying, well, why do you even think about that? Because they were not so sure. And that scientist was not very young. I keep telling you, he was not so sure in this photo. He was just thinking and thinking and thinking. After years and years passed, scientists got new technology. And as they got it, then they found out the light rays were not going in a straight line. They were going in squiggles. Not exactly this picture, but they were going where dark matter is not there, and where dark matter is there. They were not going there, like scientists thought. So that's why they're not going in straight lines. And they were going like in zigzags, like in this photo. So that's how it is. And those are some reasons why scientists figured it out. And then after that, they are way more sure that dark matter is there. Ka-ching! Okay, so that's how it was. But they will never ever say that dark matter is so true. And did you know why? Well, because since it's invisible, as I told you, they'll never see it. Unless if someone makes a good technology, like a good tool where they can see like invisible stuff from it, but that will take lots of years, so it's still a big mystery. Here's a fun fact: dark matter is everywhere, even inside bodies. It's everywhere, like in our solar system, on our Earth, and inside our bodies. As I said, that's so cool. We think that it's fresh air, but it's everywhere. Everything is dark. It's not even like air where you can feel it. You cannot feel dark matter either. That's so awesome. So here's a quick question. How much invisible matter is there, and how much visible matter is there in the universe? Visible matter 99%, invisible matter 1%. Visible matter 50%, invisible matter 50%. Visible matter 5%, invisible matter 95%. And D, none of the above. So let me give you 10 seconds. Your time starts ticking. Tick, 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 tick. Okay, time is done. So the answer was C. And what does it say? Well, it says visible matter 5%, invisible matter 95%. That is so cool. That means there is more invisible matter than visible matter, which is so awesome, as in this photo. And that means like we cannot even see all of the stuff in the universe. We can only see 5% of the universe, which is so awesome again. So that leads to dark energy. Well, 68% of the universe is dark energy, and 28% of the universe, or should I say the other way around? Dark energy, like, is 68% of the universe, 27% of the universe is dark matter, and 5% of the universe, well, it's normal matter. So that's so cool. That means there's more dark energy than dark matter, and more invisible matter than visible matter. So it might be confusing first, but after you practice and practice, then you'll get it better. So that means dark matter is so cool, and dark energy. So that leads to dark energy again. So what is dark energy? Well, dark energy is white energy in space. Yeah, not exactly this photo. It's not purple, but it's like kind of purple and white. But it's still a big mystery. Like, it's not like dark matter where that was short. Not exactly short, but short. But in dark energy, it's just a big guess. Yeah, I don't even know many about things about dark energy. Yeah, it's really ordinary. So it's like that, and detectives are still finding out. So it's awesome. And before I finish, I want to show you something which is so awesome. So you know this website called HTwins.net/scale2/. So you can go on it, and there's this thing which is so awesome. So it's like our whole universe, as you can see. So let me start from the whole universe. So there's this universe, and then there's big things in our universe, and more big things, and more big things. And then there are galaxies that are very big, and here's our galaxy, the Milky Way, and the Andromeda galaxy. That is the nearest galaxy in our, like, to us. And more galaxies. These are nebulas, more nebulas, more nebulas, more nebulas, more nebulas. These are stars that are bigger than our star, which is so cool. And here is the sun, our sun. These are stars that are smaller than our sun. And look, this is the Minecraft world, as you can see. Whoever likes Minecraft, they will like this. It's so cool. And here are the planets, Saturn, and yeah. So when you click on it, it gives facts, like Minecraft world. See, it gives facts. So you can press on it after, because I don't have time really to press all of this stuff. So it shows that Rhode Island, which is the smallest state in US, is bigger than like a star, or not star, but I meant to say like how would I say, a moon of one of the planets in our solar system. So yeah, so here's Mount Everest, here's Deimos and Phobos. Those are the two moons for Mars. Angel Falls, Burj Khalifa, Gravity, whales, dinosaurs, humans. So here's the human, and after that when you go smaller, so 1.5 done. So that means there's stuff inside. So as you can see, there's more stuff, ants and stuff. There's even the smallest object visible to the naked eye. After that, there's blood cells, viruses, more cells, more cells. These are atoms, more atoms, more atoms, more atoms. These are nucleus, protons, neutrons, electrons. These are quarks, more quarks, bottom quark. Let's see, pressing one. Top quark, the smallest quark. You go inside, you can wait up. And here's the Planck length, and here's the string. So Planck length is the smallest length in the whole universe. It's a quantum form, and here's the string. So that means there's so much out there outside our planet, but there's more things also inside the planet, which is also a mystery. So don't think that there's so much outside. There's also so much inside. So that leads so good. So that leads to that means space is so awesome and full of mysteries and universes, but inside there's also many huge mysteries. I think it's fun. So I hope you like my video, and if you like my video so much, please like my video and subscribe my channel, because there will be new videos that are so helpful. And if you have any best friend or like any friend that you know or someone you know, can you please share the video to them, because then it will be helpful. And yeah, and I hope you like the video again, and bye, see you later.